I guess.
Right. That's all right. Now you know. All right. So what we'll do today is two things. One, we'll go take a look at the homework assignment. I'll give you the correct solution to the indentation part. So once we have the indentation part done, then you can take that file. I'll post it on Moodle. You can download it, and then we can work on the tracing part. Okay, that's what we talked about last Thursday. Okay, you guys still remember that part, right? Okay, so we'll go ahead and do the first part first. Okay, and we'll double check that I'm actually doing the recording here. And the second part will be in the form of a second homework assignment, or I can change the assignment so I can upload another file, and you have to change the file name to designate, that's the one with the trace. So we'll go ahead and take a look first at the indentation part. So after our discussion on Thursday, do you guys find it, okay to do the indentation part, or was it still kind of confusing? Sorry?
I still couldn't.
You still couldn't do it? What about the?
I didn't know if I did it correctly. It was tricky.
Okay. All right. Yep.
I think the open parentheses and then the close and then the highlighting we did on the second day really helped.
Okay. So because
Yeah,
we
like-
already understand the concepts of open parentheses and closed parentheses. So using those things that you already understand and apply it to something that's new, helps to learn how to do something that's quote unquote new, but it is related to something that you know already. Yep. Go ahead.
I was gonna say, would you be able to go over the homework at the beginning of class?
Sorry?
Would you be able to go over the homework at the beginning of class?
I'm going to go over it right now.
Oh, yeah. I'm sorry.
Yep. All right, so this is the first part. I'm going to do the first part now. And I will give you the file with the correct indentation to start with your second part of the homework assignment. So here's the one that has no indentation, and we'll go through the same exercise. I'm not just going to give you the solution. I will work with you so that we can work on this, step by step, just to repeat what we talked about on last Thursday. Okay. So there are two ways to do this. There are really two ways to do it. One way is to do it from the outside in, and the other way is to do it from the inside out. We talked about the way to do it from the inside out on last Thursday, but you can also do it from the outside in. Either way, it is helpful to use parentheses on the side so that you can identify the beginning of a construct as well as the end of a construct, when we are working on this. So what we'll do is we'll do exactly the same thing, identify the beginning and the end of the constructs first, but this time I'll do the indentation from the outside in instead of the inside out. So we'll scan through the program line by line, okay? Anything that has a while, if, repeat, until, and if, else, or and while are important, okay? So we need to kind of keep a note on those things. This is a while. A while is a open parenthesis because it opens up a construct. An if opens up a construct. Another if, it opens up a construct. This is an and if, it closes a construct. And else, we don't, this is a tricky one, okay? Because an else is neither a open nor a closed parenthesis, but it is related to a open or closed parenthesis. So we'll just kind of, I'll just use a dash to represent the else here. We have another and if here. We have another and while here. So as far as opening and closing are concerned, the open parentheses are nested in this particular way. As I said a little bit earlier, I'm going to do it from the outside in. When you do it from the outside in, you have to look at the outermost portion first. The outermost portion starts with this parenthesis. Now, since we already know how to match parentheses, what is the closing of this line in terms of just matching the parentheses? Say again? Line 13. Very good. So line 13 is the closing corresponding to this line. Even if we don't know anything about while and while, using the parentheses part, we can still say open, 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 close. So this one closes this one. Close, this one closes that one. And this close is going to close that one. Is that okay? Yep.
Really quick, if you just don't have matching parentheses and you double check whatever, does that make it
If they do not match,
Yeah, like if you had 13, you had 2 and whiles.
if they do not match, it is definitely an error. Okay, the algorithm is not either considered not finished or it is incorrect.
And if that's the case, do you even work on it?
No, you do not. You cannot trace an algorithm that has problems like that. So you basically just have to say, okay, cannot trace this algorithm because the beginning and the endings do not match. They do not nest correctly. But in this case, we do have a correct match. From line 3 to line 13 is one single construct. So one way to do it is to do it from the outside in. So I would select everything in between, okay? And if you prefer, you can also do it with the parentheses side too. Okay, so I'm selecting everything between line 3 and line 13, excluding the beginning and the end themselves because they should not be indented. But everything in between, the content of that while loop are now selected. And I just do one single indentation with everything that I have selected at this point. So I'm gonna do the increase indent here. And I just want to make sure that I have enough room later on, so I just want to make sure that we make this just slightly wider, like that. Okay, so this part is done now, okay? I don't have to worry about line 3 and line 13 anymore. Now I can focus on the inside. When I focus on the inside, let's just go ahead and I'll just highlight it so that this way I know which portion is already done. So this part is done already. I can now focus on line 4 all the way to line 12 because the rest of the program is already done. I just need to deal with the nested portion now. Now with this portion, it's the same thing. I have to look at the open parentheses and the closed parentheses and find out where is the opening and the closing of something.
4 and 11.
Line 4 is the beginning of 1 and its matching is on line 11. So now we have everything in between to be indented. So just like before, I select everything in between, but not including line 4 or line 11 in this case. Select everything that is included. And the only exception is line 9. Because line 9 is the else, and the else should have the same indentation as the if and the end if. So I have to unselect this particular line just because it is supposed to have the same level as the if, the opening and the closing of the statement. Is that part okay? Does everybody understand why I deselected line 9 in my next level of indentation?
For me, it was tricky where that else belongs to the while or to the if. So
The else always belongs to if.
always belongs to if.
Because it's always if something then, and then potentially the else, and then the end if. It cannot belong to the if on line 6 to line 8, because that one is closed already by this time.
To me, like while from line 3 or if from line 4, I was kind of like,
But while has no else.
okay, then I
Right.
understand now.
Yeah, while has no else, only if has an else. Yep.
If line 9 is indented, is that incorrect?
It should be indented once.
It should be indented once like it is now, but if you indent it one more time, then it would be in the wrong level of indentation. All right, so are we doing okay so far with the selected portion? I'm gonna do the indentation now. So another level of indentation. All right, so since this part is already done, I'm going to highlight the portion that is done already. Okay, so we'll highlight this portion. And now we only have this open parentheses and this closed parenthesis to deal with. The only content is line 7, so I'm going to indent line 7 itself, and I'm done. This is the final product. This is what it is supposed to look like when you have all the indentations put into this particular program. Are there any questions about this part? Go ahead.
Can you ever use the else statement that was equals to goes to z? Is there ever?
Can we use the else, which is line 10, to
Or 6? Will we ever use that?
no, because line 6 does not belong, it has no relationship to this else here. This else is a part of the if starting on line 4. Okay. Now that the indentation is done, I'm hoping that this is kind of more clear as to which statement is containing which other statement. Is that okay or not? No? Okay.
I have no idea how to, like, I did this part right, but to
Okay.
be honest with you, as far as like tracing, like I don't know, because with the, let's say, and I know this isn't like a math class, but from like a math class, you're gonna work from the inside out anyways, like that's how you would do what
Okay.
you're supposed to do, but I don't know how to trace this.
Okay, well, first thing first, let me save the file and then upload it to Moodle first, okay? Because I don't want to, miss that portion. And since I downloaded my own document back, I should have track changes already turned on, which means for those of you who want to kind of backtrace what I did, you can actually go through the log and actually see how I made changes to this program. So on top of the recording of the lecture, you can also rely on the log in the file itself to figure out, how I did it step by step. Okay. And to do it, you can go to Edit, go to Track Changes, and then you can say Accept or Reject. And then it will pop up this box here, and you can go through this box, and it shows you which part of the content is modified when. So that's but it doesn't show indentation. Unfortunately, it doesn't show the indentation action of the entire thing. All right, so let me save the file again, and I want to keep it open, but I do want to upload this document. So the way I'm going to do this is, okay, this is what I'll do. I'm going to edit settings here. And what I'll do is I'm going to change this to have 2 uploaded files. So don't delete, well, okay, never mind. I don't want to run any chances of someone deleting what is already turned in. So I'm going to start a new homework assignment, and in the new one, you just turn in the one with the trace, and you can start with the file that I just created today. Okay, so this one is done already. I'm going to start with a new homework assignment. I just could not decide earlier, what to do, because I can increase the number of files that you can turn in with a particular homework assignment, but that means, someone can also potentially delete a file that is already uploaded that I have not graded yet. So instead of doing that, I'm just going to open another homework assignment, and Moodle makes it kind of easy because I can do a duplicate. And it just makes changes to the duplicate itself. A little bit sluggish today.
So,
Question?
since there's only one else, like, there could be, that's later, but there could be 2, right? That's why that-
Potentially there can be 2 else's, correct?
Or more.
Else if, okay, you're talking about else if?
Yeah.
Yeah, one if can only have one single else, but you can have any number of else ifs in between the if and the else.
Okay. And if, I guess in this case, that's why it's only indented once, because it's part of that section. But if there was another one, then they have to be indented differently, right?
Correct. And I have to change the file name because otherwise it will complain about the file being the same file name. So I'm going to have to change nested to nested 0900 trace.ods. So now they're distinct, 2 distinct files. Go to the temp folder. Yep.
Can we just rename the old assignment and turn it back in?
If you want to use your own file, definitely. But for those of you who do not want to use your own file, you can use my solution of today as well. So that's all good. And this one, I'm gonna put trace only inside the title of the homework assignment. And I will delete the portion that you don't need to do for this one. You still have to create sheet 2 as your trace.
It's the top.
Oh, it's the top part?
The top part. First fix the indentation.
Okay. So this part is now removed because it's already done. And the homework assignment name has changed to nested statement trace only. And
Do we have to create the sheet 2 or we have to?
you have to create sheet 2 because the spreadsheet does not come with a sheet 2, so you have to create it.
Really, if I redone the sheet 1.
The trace you have to do on a sheet,
no,
on a separate sheet.
The today's homework.
Today's homework, you just do it in place.
Okay.
Yeah. Or if you do it on a different sheet, that's fine too.
Okay.
Not a problem. And I'll make this one due on the 27th. Same time. And save it. There we go. So now you have the second part of the same homework assignment. Okay, let me just go back to the document first because I do want to tell you guys how to proceed with this homework assignment. The best way to do it is to draw a picture of this first. Okay, and I can even give you a rough draft of the picture. Okay, I'm not going to give you all the details because that's something that you need to work on because this is the kind of code that we'll be dealing with for the entire semester. So it really is helpful for you guys to be able to do it yourself. But basically what you need to do is to think about a loop, okay, as a block. In other words, a loop from line 3 to line 13 is a particular type of construct. Now you have to remember what it looks like in terms of its shape, okay? But you do remember that there's one big chunk that you have to specify as the quote-unquote content of the loop. So what you need to do now is to say, okay, but where's my conditional statement from line 4 to line 11 relative to the loop itself? So let me label this one as my while loop here. So the question now is, where's my conditional statement? Well, the conditional statement from line 4 to line 11 is entirely contained within the while loop here. So in terms of the structure of the code, the outer conditional statement, the if conditional statement, is contained within the while loop. I left some space here because there's another statement after the outer conditional statement, so you cannot forget about that one. But it is not structurally as important as the conditional statement from line 4 to line 11. So I'm going to leave this part to you guys to decide, okay, but which one is going to go here? I'm not going to say anything here. Okay, so inside the conditional statement from line 4 to line 11, it has two main parts. One part for the then portion, which is what we do when the condition is true, and one portion for the else portion, which is what we do when the condition is false. Instead of drawing that this way, I'm going to draw it like this, okay? To kind of match the way we usually draw a conditional statement, it has a then portion and an else portion. Okay? What about the inner conditional statement from line 6 to line 8? Which way does it belong to, the left-hand side or the right-hand side, using my usual convention?
Left.
On the left-hand side, correct. So the left-hand side now has its own little conditional statement, which has its own then part, and not really the else part, but it has an alternative branch. Okay, just like any conditional statement. The only question is, do we have anything to do with the else portion of the inner conditional statement? It doesn't spell out the word else, which means there's nothing to do for the else portion, but the structure is still the same. You still have to make a decision. Do I go, from your perspective, do I go left or do I go right? Okay, normally there's something to do on either side, but occasionally there's nothing to do on one side. Is that making sense so far? So when you draw your picture, it's not going to look like this because you would also have to indicate the paths, how they merge, how they go back, and stuff like that. But for the most part, it is nested like this. Okay, you would have constructs within constructs like that. Is that helping or not? Not helping?
Not with the
Helping a little?
indentation. I guess for me it doesn't help with the indentation. But I get it. I'm just saying.
Okay. It's just like, when you create folders, you can have a folder within a folder. But once you're inside a subfolder, you don't have to worry, okay, am I inside of this subfolder or the other subfolder? You can focus on where you are at that point. I will address that. Let me answer his question.
Oh, really quick. I forgot for some reason how you the sequence how you do it, do you highlight the first whole thing, or you start in the very center? Like with the indentation, like for example, between 6 and 8,
Yeah.
there's that one indentation on 7 by
Right.
itself. You do that first, right? And then you go outside of it? Or
That's up to you to decide.
Oh, okay. It
On
doesn't-
last Thursday, I did it from the inside out, and then today I did it from the outside in. So either way works, because as long as you can match the parentheses, you'll be fine. Let me answer his question anyway. Yep, go ahead.
So can the while loop have two nested states? So like while z is less than 5, do the if then statement, and then we do the if then statement, but at the very bottom you have that x plus, on line 12 you have x plus 1, so we do
Right.
the if then statement, because x will never change in value unless we go to line 12. So we do the if then we do 12, and then we repeat the loop.
That is, well, you're.
Okay. I'm just asking.
You're kind of spelling out the answer for the whole class, but that's kind of okay. Yeah, go ahead. Oh, attendance. Thank you. So I'm gonna cross out the day that I forgot to pass out the row sheet, so we don't get them confused here. Everything's all scratched out. And now let's start with you guys. All right. Any questions? Yep, go ahead.
So if you're going line by line, because I was trying to figure out the indentation a little earlier tonight, I didn't figure it out. But is it possible to just go line by line and figure it out, or
If you go line by line, you can identify the beginning and the end of something, but whether you can tell what it is ending when you encounter an end is entirely up to you. I mean, some people can do it. I can do it. Just by scanning it, in one direction, and keep track of how many things are open at the time, and what is closing, what is being closed. But if you do it the first time, if you just do it the way that I did, that would make it easier because you're just counting open, open, close, close, and so on. So that makes it easier. It's not any different from matching parentheses when you read a regular expression in a math class.
right?
It's just that we are not putting things in a horizontal way. We're putting things in a vertical way. Okay. Any other questions? No other questions? I'll do one example, maybe, of an algorithm, and I'll just go ahead and draw the structure. But after I draw the structure, it'll be up to you guys to, actually finish the code. So let's see. I'm gonna do bubble sort and see if there's one pseudocode that is appropriate for as an example. Okay. It uses a for loop, which is not what I wanted to do. All right, so I'll just go ahead and use this as an example. Forget about the procedure part, and don't even worry about what is an array. We are just looking at the structure of the code here, okay? So we're just looking at this portion of the code. Don't worry about, what is exactly a loop, a for loop here. A for loop is kind of like a while loop, with a spin. So we'll just consider, the for loop as a while loop. Okay, so we'll just take a look at this. I'm going to draw the picture on the whiteboard. And I need a pen that is usable. They usually have like a whole pile of dry board markers. I cannot find any. Well, since I cannot find any, I'm just going to use my rather bad, drawing skills, so we'll do it this way too. We can do it this way. And I'll draw it from the inside out because this way I can use the zoom feature, to resize things a little bit just to make it easier to read. So I'm going to zoom all the way in, and our focus is this part first, okay? All right, so we'll focus on this part. Now, without even knowing what is, A bracket something and whatnot, if you just look at the entire thing, what kind of a control structure is it? Okay, I'll let you guys select. Is it a pre-checking loop, repeat until? No, sorry, a pre-checking loop is a while do. A post-checking loop, which is a repeat until, or is it a conditional statement? It's a conditional statement. Okay. So with any type of conditional statement, I know what kind of shape I have to draw to represent it. Okay. So I'm just going to draw a conditional statement here, and I'm going to do some, rather bad hand drawing. Okay. So we have a conditional statement. It has a branch, and then we got potentially something to do on each side. Sometimes we don't, but that's okay. All right, so here's my conditional statement to match this code here. Is that okay? Now, my focus is not even what to do. My only focus here is what is the structure of this program. Okay, so I'm not even worried about what is a bracket, I minus 1 close bracket. Is it multiplying a to I minus 1? We don't care at this point, okay? We just know it's a conditional statement. It has a condition to evaluate. If the condition evaluates to true, we go to one portion of the structure. If the condition evaluates to false, we go to the other one. But both branches have to merge at the end, and that's all that we care about. Is that okay? All right. What is enclosing this conditional statement? Well, whatever that this for and and for is, okay? From the indentation, we know this is the beginning and this is the end of that construct. That is important because that tells us, where's the start of this and where's the end of this. Is that okay so far? Using the indentation to help us understand which construct is containing which other constructs. Is that okay? Oh, you know what? I forgot one thing. How many things are we supposed to do inside a conditional statement? We got two things, okay? We got a sequence. We got whatever the swap is supposed to do here, and then we have whatever new n is equals to n is supposed to do here. So there are two things we have to do inside the conditional statement. To represent that in our picture, I'm just going to be lazy and draw like two rectangles here to represent the two statements inside the then portion of that statement. Now, because the statement does not have an else, that is equivalent of saying the else branch has nothing to do. So that's why I'm leaving the else branch just kind of blank the way it is. Are we doing okay with that part? That's okay? All right. So that means if we switch back to this part here, we are now done with this part of the program. The structure of this part of the program is all done already. But what about the rest of the program? Well, I'm working my way, from the inside out. So now we look at the for loop, for and then the and for thing. As far as we are concerned, for and for is a special kind of while loop. Okay, so you can just consider this as a while loop. So now we go back to the picture and then we zoom out a little bit, and then we ask, okay, but how do I draw a while loop? What is the shape of a while loop? Okay, you have, well, it's kind of weird, right? You have two ways to come in because you have a way to go back and then come in through the same point. But when you do come in, you have a choice of either leaving the loop or you can continue with whatever the loop is specifying. So we'll draw the picture of the loop first, and then we'll fit this thing inside the loop. So what I'm going to do is I will move this one aside first and then draw the picture of a while loop. So the picture of a while loop, has a way to come back in, and we can choose to get out of the loop like that, or we can choose to continue with some kind of statement inside. But when we are done with that statement inside, we have to go back and reevaluate a condition. So now we can draw the rest of this picture. Go, and one last portion, which is here. Okay, well, not exactly the best hand drawing, but it suffices, right? It represents the structure of a while loop. Is that okay? What am I going to do now? who is containing whom? I have two things, okay? Each one seems to have the ability to contain something else. So the question now is the left object being contained in the right object or the other way around?
First one, the left object is being contained in the right object.
Right, the right object is the nesting, is the bigger one, right? So what we'll do is we'll do exactly that. Okay, so we'll take this one here and say, well, we don't have that much space. Why don't we shrink you, make it a little bit smaller until it fits into the other one. Drag it over and just put it here. Is that okay? Well, I know it's really bad drawing here, but the concept is that, okay? You have one thing that is now completely contained within the other thing. So what do you do when you trace this particular algorithm? When you, okay, let me just kind of zoom into the portion that I want to talk about first. Okay, so I'm just going to focus on this part here. So when you come in from here, what do? Well, you first have to make this branch, make the decision, right? Because that branch is the first one that you encounter. In other words, there will be a question that you have to answer in order to decide whether you leave the loop or whether you stay in the loop. So you have to answer this question first. If it is false, you take this branch. If it is true, you take this branch. So after you take this branch, which is the branch corresponding to the value of true, what do you do next? Well, you're into this conditional statement. So when you're evaluating the condition of this particular conditional statement, then you have another choice to make. Am I moving in this direction or am I moving in this direction? Either way, they will merge. After they merge, you get to the exit point of the entire loop itself, the inner loop in this case, and then that will go back to the beginning, and then you will start, you will do the whole thing again. Is this part okay? It's a trail within a trail, okay? Or you can look at this as, okay, you can look at the while loop here as the interstate map, okay? You're looking at the outer level of a map. This is the interstate route, and then whatever is inside this loop here is the inner map of a city. In other words, if I just tell you, oh, you can take Interstate 80 west to get to Davis, okay? That's really just talking about the outer portion of the construct here, okay? But once you get into Davis, how do you get to, let's say, UC Davis? Well, I can give you a more detailed map, which is the inner portion here. In this case, it's the conditional statement. Now, within the conditional statement, within UC Davis, I want to go to the College of Engineering. How do I get there? Well, then you look even one level inside to figure out, okay, there's more detail to tell me how to get to the College of Engineering. Is that making any sense? Now, if you look at one of these yellow red blocks here, it itself can also be a loop, a conditional statement, or another sequence, which means inside the College of Engineering, how do I find a particular lab? So we can use this concept of nesting in map navigation to find a particular place, or also in the case of describing an algorithm, what do we do when we have constructs nesting within another construct? Is that okay so far? Now, what have we done so far with this picture? Now, we have completed this portion of the algorithm. There's one thing that we can do that we have to do before that loop, and one thing that we have to do after the loop. So if I want to represent those in this particular picture, then I have one thing to do before I get into the loop. So I'm going to use this block here. So I got one statement here, before, and I got one statement here, after. So right now I have just represented the inside of the repeat until loop. So now it's time to give me the overall structure of the repeat until loop. Okay, what does a repeat until loop look like? It's not like a while loop because it's a post-checking loop. So, excuse me, it's not a pre-checking loop. A repeat until loop is a post-checking loop, which means you don't really get a choice. You have to perform an operation first. But after you perform the operation, then you have a choice. So at that time, you can either choose to go back to the beginning, and I'm not sure whether this is, oh, I think that's okay. So you can either go back to the beginning, or you can proceed to get out of the loop. So let me indicate the direction here too. Okay. That's a direction, that's a direction, and that's a direction. There we go. Doesn't look very good, but it is the shape of a post-checking loop. Is that part okay? I mean, a post-checking loop means you have to perform whatever operation is specified in between first, and then you choose, can I get out now? Is the exit condition true, or is the exit condition false, which forces me to go back and perform another iteration.
So repeat is a pre-checking loop, and you have, or
Repeat is post-checking.
And regardless of the condition, you do it until you come back around, and it's not.
You perform the operation, and then you check the condition. Can I exit now?
So if I have repeat until x is greater than 5, but if x starts off as 6, what do you do?
Then you still have to do whatever is specified, because it's a post-checking loop. You perform the operation, and then you check the condition.
Okay.
So you have to be careful with it. It's less common of the two. Okay, the two kinds of loops, pre-checking loops are more common than post-checking loops. So that means this entire thing, I know this is going to look really bad, because what I'm going to do is to take this whole thing and shrink it. I suppose I can just squish it like this, like that, and put it inside this loop here. Okay, I can make the other one bigger too. There we go. Now we can just put it here, like that. But you can see how I constructed the picture, right? I constructed it one step at a time. There's only one more thing to do. The one thing that's left to do is there's one statement before the repeat until loop. If you go to the pseudocode here, there's one other thing that I have to do, which is n gets the length of a. So I get back here, I represent that thing just using a bar, like so, and that represents the overall structure of this particular pseudocode. Are there any questions about the steps of creating this picture? Because it is the steps of creating this picture that is important. It's not even the algorithm itself that is important. It is the step that you take to start with the pseudocode and then come up with a picture. Once you have the picture, then you can just follow the logic that is represented in the picture to trace the code. Is that part okay? Are there any questions about the procedure itself to do the translation? Questions? All right. But this whole thing is recorded, so if in case you need to review, what I just talked about today, it is going to be online on YouTube when you. Well, I will do it as soon as possible. So when I teach the next class, I'll be uploading this one. All right. So I'm hoping this is okay for now. Then we can go back and talk about the pre and post condition thing, which is a kind of important topic all on its own. All right, so getting back to the pre and post conditions. And I think last time we talked about loops, right? So that was pretty much the entire topic. Does anyone remember where I left off last time? I can just check my own recordings too, so let me just check it. That's one really good use of my own recordings. And last time it was 5 days ago, and this is the 0900 class. Also using that theorem as a basis of his own thesis. Oh, and I told him, talked about well, that. you know what, I found that this theorem was not true. Okay, I found a counterexample. So we haven't started on loops yet in this class, have we? Nope. Okay. Say again?
You're going to start on loops yet?
In terms of pre and post conditions, have I talked about how to analyze a loop that has a pre and post? Okay. All right, so let's start on that one because it's really kind of an interesting topic too. All right, so let's go ahead and get started with this. And I'm going to use my mouse pad here, just like using it as a whiteboard. And here's my loop. My loop is just saying if while x is less than k, do the following. Line 2, x gets x plus 1. Line 3, and while. Okay. We know this kind of loop, but I cannot trace this one. Why can't I trace this particular loop?
We don't know what K is.
I don't know what x starts with, and I don't know what k is. So there's no way to actually trace this code. Okay? But the question, the other question now is, can I analyze this loop and say, if I start with a certain assumption, then I'll be able to come to a conclusion about what has to be true by the time I get out of this loop. You know, what if there's a line 4, okay? What would be the precondition of line 4? That really is the question of post 3. Okay, so let me just kind of write it down here, okay? If I was told that pre1, the precondition of line 1, is just that x is less than k, can I derive post 3 so I can conclude what has to be true when this loop finishes? That is the question. Okay? Because tracing doesn't work anymore, because tracing requires that you know the exact value of every variable in order to perform the comparison. But since I was only told that x is less than k before line 1 executes, that's the only thing I was told, can I still do something useful and come to a conclusion and say, well, you know what, when I get out of this loop, this condition has to be true. Okay, that's what I'm trying to accomplish here. Okay, so let's go ahead and take a look at how we are going to analyze and finish with this analysis. What can I say about pre2? Okay, pre2 is basically stating if I'm just about to execute line 2, what condition can be guaranteed? Okay, pre1 can be guaranteed sometimes. Okay. So this is also where it helps to draw a picture too. So I'm going to switch back to my Inkscape here. I'm going to remove this picture or start a new one. Let's just start a new one. New letter size. It's helpful to have a drawing tablet in this case, because using a mouse to draw pictures is not exactly the best way to do it. But it's okay, I can still do it. This is a fairly simple picture too, because there are only a few things to do. Okay, so we'll draw a post-checking loop. So a post-checking loop looks kind of like this. Okay, we have a way to get out of the entire loop, like so. And then we have to come back in after we perform an action, and the action is specified here. Oops, no. Okay, let me redraw this part. Okay, here's my action, and this is the part where we get out of the loop. All right, that's close enough. Fine. Okay. So now we want to label, our question too, because we want to know what kind of question do I have to answer to determine whether I'm exiting or not. So the question is going to be stated here. Unfortunately, I do have a text tool here, so at least I can type something and not having to hand draw it here. And I can pick a slightly larger font, let's say 18 point. And the condition is x is less than k. This branch represents what we do when the condition evaluates to true. This branch indicates what we have to do when the condition is false. Inside this action here, we have x gets x plus 1. And that's, this is representing the pseudocode that we were talking about. Is that okay so far? Okay. We have the pseudocode, we translate it into a picture. the reason why I want to translate that into this picture is I want to show you where the pre and post conditions are located. Where's pre-1? If I want to draw a circle to represent pre-1, where am I supposed to draw that circle?
At the top.
At the top. Okay, very good. So the precondition is here, and I'm going to change this a little bit so that it's easier to read. Okay, so we go to object, and we go to fill and stroke. And I'll just reduce the opacity so it's kind of transparent. There we go. That looks good. There we go. So now I can just do a little caption here to indicate this is my pre-1, which is the condition that is guaranteed to be true when we first get into the loop. Is that okay so far? Okay. Where am I going to put pre-2? Okay, so it'll be right about here. Okay, so let's go ahead and do that. I'm just being lazy and using copy and paste. And we'll change this to pre-2. Oops. All right. And where am I supposed to put post-2?
Bottom of that square.
Okay, bottom of the square. Okay. Post-2 is kind of interesting because if I just kind of duplicate this first, I can put post-2 here or anywhere within this branch back, right? Because nothing happens during that portion of the branch. Okay, so keep that in mind. So I'm going to put it here and label this my post-2. Okay, this is pre-2. Pre-2 is over here. And I'll just go ahead and duplicate it over here. And this is my post-2. This is the post condition of line 2. And where's my post-3? In other words, where's my condition that states what has to be true when the entire thing is done? The bottom. Okay, very good. Okay. All right, so we'll go ahead and write that down. So once again, I duplicate it. I can put it here or anywhere along this line. But to make it very clear, let's just put it all the way at the bottom here. And then we'll take a look at, oops. This is post 3, which is the post condition of the entire loop. What do we know for sure that has to be true when we get out of the loop? Okay.
Where's post 1?
Where's post 1? There's no post 1. And I'll explain why there's no post 1. Let me move things around a little bit so that this true here. Okay, something is interfering with my. Okay, we'll just put the true here and then put the label highlight back here. All right, there we go. Okay, so the question is, where's post 1? Well, I cannot say anything about post 1 because there are two ways to proceed after the branch. So it doesn't make any sense for me to talk about post 1. Are we doing okay so far? Okay. If I get back to the pseudocode, here's line 1. Now post 1 basically says what has to be true after line 1 executes. Well, it can be two things, right? Because after line 1, it is possible that x is not less than k at that point, and then I get out of the entire loop. It is also possible that x is less than k, then I proceed to line 2. And since I don't know which way to go, I cannot say anything about post 1. But I can say something about pre-2, because which is one way to proceed from line 1, and then the other one is post 3, which is another one to proceed from line 1. So that's why we don't talk about post 1. We use pre-2 or post 3 to indicate one of the two branches that we can get to after line 1. Is that okay? Does that answer your question? Very good. All right. So what is pre-2? Well, pre-2 is kind of interesting. Let me just see if I can superimpose, or not superimpose, but put the picture on top of the text. So we'll go ahead and give it our best shot, okay? Let's make this like this. And I can even just hide one portion of it and then show the note here and then show the picture back again. Excellent. Okay, so now we can look at the picture and also mouse pad at the same time. Okay, so how am I going to express pre-2? Just using this picture here.
X is less than K.
X is less than K. Okay, that's for sure, right? X is less than K is a guaranteed condition. And let me go change one little thing so that I don't have to hide one screen while working on the other one. Click to focus, focus, follow mouse. There we go. All right, so this way I can type without having to cover the other screen. All right, so X is less than K has to be guaranteed because it doesn't matter, the only way, doesn't matter what is, it doesn't matter how I get here, but in order to end up at this point here, X is less than K has to be true. That makes perfect sense, okay? But then I have another question now, because there are two ways to really get to this point. One way to get to this point is from pre-1. This is the first time we get to this place. The second way we can get to this point is after at least one iteration, then we can get back to this point again. Is that okay so far? Does everybody see there are two ways to get to this point? One is from pre-1, straight down here. The other one is using this merge point so that we do it after at least one iteration, then we get back to this point. Is that okay so far? So that means the condition that goes along with this one is, well, you know what? I can come in here through pre-1. I can also come into here through post 2. Is that making any sense so far? Sort of. Okay. Yeah, the X is less than K part is the easy part because because we can only take that branch and end up here when X is less than K is true. But the other part, the OR, is a little bit more confusing, and that has to do with the merge point at the top of the while loop. It has to do with this merge point here, so that I can come in through here the first time, and or I can at least perform one iteration first and then get back to exactly the same point. But doesn't that kind of make it harder to analyze the condition here? Because now, what am I going to say about post 2? I know what pre-2 is, but what can I say about post 2? That's kind of hard because now we have a self-referencing kind of thing going on, right? Because pre-2 depends on post 2, but post 2 in return also depends on pre-2. So we have a little problem here. So let's not worry about this problem, and let's go straight to post 3. Maybe we can figure out post 3 without figuring out the rest of this code. How do I get to post 3? What is the condition that has to be true by the time we get to post 3?
X is greater than or equal to K.
X is greater than or equal to K is guaranteed. Yes. So X is greater than or equal to K is something that has to be guaranteed, because otherwise we would not be taking the false branch out of the loop to get to post 3, get to the exit point of the entire loop. Okay, that's guaranteed. But then we have, once again, those two things again. Because in order to get here, I can go from here and then immediately take the exit branch and go all the way to the end. Or I can go through here, perform at least one iteration, and then choose to exit after at least one iteration. So that means I end up with exactly the same thing as last time, which is pre-1 may be true at this point, or post 2 may be true at this point. Now, all of this stuff here has to do with the structure of the code. Okay, it just has to do with the structure of the code. Are there any questions about the pre and post conditions in the way they're expressed at this point?
I guess it's not really about the way it's expressed. It's more like, what are we figuring out for? I guess I'm wondering trying
We're
to
giving
figure.
up to post 3. I want to know, I want to say something.
Not specifically this, but the point of doing this. I'm trying to figure out like what the end game is for
Okay,
doing
this,
this.
okay, this has to do with automated verification or validation. In other words, someone can give me an algorithm, tell me assumptions, before the algorithm executes, tell me what the program is supposed to accomplish as a math equation, and my job is to see whether it actually gets it done or not.
Okay.
And this is one step of that entire process.
So this is just the the beginning portion of that process that you would take in order to do
it's
that?
one step, I would say this is one link of that chain. Because, a loop can be one part of the entire pseudocode algorithm, right? So this is basically how do we handle one link of the entire chain, and I need to be able to handle each link first, and then I can chain the entire thing together from the beginning to the end. Then I can start with the precondition, which is a guaranteed condition when this algorithm starts execution, and then come to the post condition of the entire algorithm, which describes the property of all the variables when the algorithm comes to an end. And then I can use that post condition of the entire algorithm and compare that with the specification of the algorithm and see if they match. If they match, we're good. The algorithm does work, and I don't have to throw a single test case to the algorithm to see whether it works or not. Now, if they do not match, then I have a problem, because I know the algorithm, at least for certain test cases, will not work. And this is one link of the entire chain, because an algorithm can be very complex, but it has to break down to assignment statements, conditional statements, pre-checking loops, or post-checking loops. So we're trying to handle each and every single one of those individual pieces so that the entire thing can be done as one chain of all these little links. Okay. That's a good question. It's good to keep an eye on the big picture and not just look at the details. Yep.
It sounds like it's more important for security programming kind of thing, because
Absolutely.
and less so for like game design, because then they have bugs and they could just
They can charge money for the fixes, right?
Yeah.
You want to get back to your game? It's time to pay up. Oh, I can see that you have a PayPal account already linked to your game account. Very good. We'll notify you that we have charged you X many dollars, right? We're not going to ask you for the permission. We'll just let you know that we just did it. Or you might notice that you cannot get back into a game. But what happened to my upgraded shield? It's now wooden again. I think that would be a great way to charge money. It's like, if you don't pay, we'll just automatically downgrade your stuff. Your super duper, diamond shield one day will become paper. It's like, oh, what am I gonna do now? You can't even stop a water gun. All right, so getting back to this one here, I would say post 2 is kind of important, because post 2 appears here inside pre2. Post 2 is by itself kind of important, and post 2 is also a component of post 3. So it is something that seems to be, true almost all the time, right? I mean, that's kind of important. Let me get rid of this first, so I can slide this thing over, and then slide this one back to here. All right. So post 2 has a special name because of it, because of its importance here. It has a special name. Its name is a loop invariant. Okay, so I'm gonna write here and say post 2 is known as the loop invariant. Loop invariant implies what? What is it implying? It's fixed. Okay, it does not change. Okay, because vary means changing, right? So invariant means it is the one thing, the one condition that is true the whole time. It is true when you're in the loop, when you're looping, when you're doing something over and over again. It is still true when you get out of the loop in the post condition. So it has a significance like that. In this class, I'm not going to tell you guys how to find out what is the loop invariant, But instead, what I'll do is I'll tell you, let's check this out, see whether this will fit the bill. If this is the loop invariant, will everything work out okay? So that's what we'll do, that's how we'll approach this problem in this class. Okay, so let's say tag things, the loop invariant, post2, is just x is less than or equal to k. Okay. The question now is, will that work out? Okay, is it going to be consistent with everything else? Because what I have here, from the pre-condition of line 2 to the post-condition of line 3, I have a framework. Okay, I have a framework where one of the components, which is post2, is unknown. Okay, I don't know what it is, but it has to conform to the constraint of this entire framework. So the question now is, if I just say, okay, I have this vision, that post2 is x is less than or equal to k, I can plug it in and see whether it works out or not. Because if it doesn't work out, that means that cannot be post2. If it does work out, that means, hey, I'm done. Okay, I just found the post2 as a condition. All right, so let's see what happens when I do something like that. So we'll look at pre2 again. Pre2 is x is less than k, and oh, by the way, what is pre1? If you just, pre1 is already given to you, and it is x is less than k. All right, so that's okay. We'll just go ahead and copy that, okay, without even asking what we can do with it. We'll just copy that. And what did I just say about post2? What was my vision? X is less than or equal to k. And once again, I'm not going to talk about why I think x is less than or equal to k. Let's just say that I was thinking about this problem when I went to bed last night, and I woke up and say, oh, x is less than or equal to k. So it's a dream vision, okay? But I can at least check to see whether it works out or not. All right? All right, so now we have something that looks like something can be done to get it simplified. Do you think I can simplify this a little bit here? Let's look at the OR condition first, okay? Let's see if we can simplify something, with the OR part here, okay? So we'll focus on this part. Can we simplify this? X is less than k, or x is less than or equal to k?
X is less than or equal to k.
Yep. That was your answer too? Okay, that was the right answer. This whole thing simplifies to just x is less than or equal to k. Is that okay or not?
Are we presuming that x is going to be an integer?
Yes.
Okay.
Yep. That comes in handy later. Okay, but not right now. Okay. That's a good question. I know where you're thinking. Where you go. Okay. So now can we simplify it this way? X is less than k and x is less than or equal to k. This simplifies to
X is less than equal to.
nope. In this case, it is just x is less than k. Because it's an and, it's a conjunction. So when you have a conjunction, when you look at the two sides of a conjunction, if one side implies the other one, okay, that is the side that you keep, not the side that is being implied. Okay, so this is getting back to our discussion. Remember, maybe a week or so ago, we talked about if, only if and only if. Remember that? Which one is sufficient? Which one sufficiently implies which one? Okay, we're looking at x is less than k as one condition. We're looking at x is less than or equal to k as another condition. Which one implies the other?
X is less than k.
X is less than k is implies x is less than or equal to k. Very good. Okay, it is the sufficient condition here in this case. So in the case of a conjunction, we keep the sufficient one because the other way around does not work.
So you never keep the equal to.
In this case, we do not keep the equal to because we want to keep the more restrictive condition and not the more general condition in a conjunction.
So you on the pre2 on that first line, where you have x, where did we get x is less than or equal to k? Is that from the post2?
Yeah, that was my vision from my dream.
Okay. So you just threw it, we're testing to see if it.
We're testing to see whether it works, right?
Okay.
Yeah, because in this class, I don't want to get into, how do we figure out the loop invariant, because that's a little bit more involved. So we just want to verify and let's see whether it works out or not. Okay, so pre2 is now done. Now that pre2 is done and we know it is just x is less than k, can we say something about post2? Knowing that line 2 is only going to add 1 to x. We kind of know something about this already, right? If we know that before the increment of 1, x is less than k, then we can say, hey, you know what? After x is incremented, we just have to subtract 1 from it, and that will still be less than k. Is that making any sense? Because we're just undoing the increment operation so that we can maintain the relationship. So that means, at this point, we can just say, hey, x minus 1 is less than k after line 2 performs its operation. Is that making any sense? All right. Well, that doesn't match, my dream vision, right? Because my dream vision is to say x is less than or equal to k. But in reality, after I do the derivation, I end up with x minus 1 is less than k. Now, let's go ahead and change this one just a little bit so that we can re-express it as k plus 1 on the other side, and one side is just k. Can we still say that this implies x is less than or equal to k? Can that be done? Can we put some extra restrictions on the type of values that x and k can store so that we can perform this implies? Now, we know in general that is not true. Okay? We know in general it is not true because these can be fractional numbers. But what if I restrict that x and k must be integers? In that case, can I guarantee that if x is less than k plus 1, then x is less than or equal to k has to be true? Well, think about the number line. Okay? Think about the number line. So we have a number line here. We have x, and large numbers goes in that direction. So we have x here, we have k plus 1 here. All right? Is that okay? So the question now is, if I know that x is here, k plus 1 is here, can we say that x is less than or equal to k, assuming x and k are both integers?
Are the negative numbers included in integers?
Yeah.
Yeah.
Yeah, it works. It does work out. Okay. If x is less than k plus 1 and it has to be an integer, both have to be integers. Okay. X is an integer, k is an integer. If k is an integer, does that guarantee that k plus 1 also has to be an integer? Yes. It does, right? Because 1 itself is an integer. Integer plus integer must be an integer. Okay. So if I know that x has to be less than k plus 1, what is the largest value that x can possibly be in order to make x is less than k plus 1 true?
Okay.
K. All right. So that means x can be as large as k and still fit that requirement. So that if I draw the number line representation, that means everything from here and back can be a value of x, including k itself. Is that making sense so far? All right. So that was a good question. You had this in mind when you asked that question, right? All right. So that means it all works out so far. So if this is all working out, then I can actually go to post 3 and see if I can come up with the final answer. X is greater than or equal to k has to do with the structure of a pre-checking loop, because in order for a pre-checking loop to get out and exit, the condition of the pre-checking loop itself has to be false. So x is less than k has to be false, which means x is greater than or equal to k has to be true when we are at the exit point of a pre-checking loop. So that part we kind of know already. We also know what is pre1. Pre1 was given to me that x is less than k. And now we also have a good suspicion of what is post 2. Post 2 is x is less than or equal to k. It has worked out up to this point. Okay? So now we can go ahead and try to simplify, first of all, the or in the inside. This is the same thing as last time, right? We have x is less than k, or x is less than or equal to k, and the answer is we keep the more general one, because this is a disjunction. In the case of a disjunction, and one condition implies the other one, we keep the one that is being implied and not the implying version. So in this case, we keep x is less than or equal to k. Is that okay? Does everybody understand why this condition implies or is just the same thing as that one by itself?
Is it because you're kind of repeating the or part? Because it could be less than, and it could be or it could be.
There are two ways to look at this. One way to look at this is like this. What exactly is x is less than or equal to k? What is it really saying? It really is saying the same thing as x is less than k or x equals to k. Is that part okay? So if you plug this, and I'm going to do it exactly like that here. If you plug that part into here, okay, let's move this one over a little bit here. Don't you think this part is kind of redundant?
Yeah.
X is less than k or x is less than k. If I combine the two into one, I'm not losing anything, right?
Yeah.
So if I combine these two into one, then I end up with just that. Whoops, I forgot. No. Take it back. I removed the wrong part here. Okay, I should be highlighting these two. They're the same, right? So I can get rid of one of them without changing the meaning of the whole thing. So if I get rid of this one here, then I end up with just x is less than k or x equals to k. Isn't that really just a long way of saying x is less than or equal to k? There you go. Okay. So now we have the third derivation, which is down here. Can I simplify x is greater than or equal to k and x is less than or equal to k? Is there an intersection of those two segments of the number line? X equals to k. Exactly. There you go. That is my conclusion. Okay. So let's go back and look at the entire thing so we have a kind of overall view of what we have just accomplished. Yep, go ahead.
But this only stands for integers. It wouldn't stand for any fractional value.
That is correct. It only works for integers. But integers are more important in everyday type of programming, much more important than real numbers in programming. So this is actually a very important result. Okay. So let's go back, just take a step back and figure out what we have done so far. We started off with an algorithm, relatively simple type of pre-checking loop. We start off with an assumption. Okay, somebody told me, Tack, you know what? There's one thing you can assume when we get into this pseudocode. Pre1 or the precondition of line 1 is x is less than k. X is less than k is true, is guaranteed. Okay, before we get started. And that's it. Those are the only two things I start off with. The algorithm itself and an assumption that was given to me. Okay? And then after that, we proceeded to draw a picture representing the pseudocode, which looks like this. We labeled all the important points. We labeled pre1, pre2, post2, and then post3 according to this algorithm. From the structure of the pseudocode or the pictorial representation of the pseudocode, we derived this little framework here. I call this a little framework because it places restrictions on post 2. In order for post 2 to work, it has to be able to fit into this little structure here. And then the only magical part of this discussion was I got the vision of post 2 maybe just x is less than or equal to k. That's the only part that I did not explain in details. But I did tell you, if I put it in, will it work? In other words, if Tech for whatever reason suspects that post 2 is really just x is less than or equal to k, is it consistent with the framework that we have worked out before from here to here? And the answer was yes, it did work out. Because in that case, if I make that assumption, pre2 is just x is less than k, but since I'm making the assumption x and k are both integers, that also means that post2 works out to be x is less than or equal to k, which is exactly the way I described it here, x is less than or equal to k. Once I work out what is post2, I plug it in to post 3 so that I can figure out that post 3 is actually just x equals k. So that's basically the overall picture of this entire discussion. Yep.
Last part where it says where you decide that x equals k, is that because greater than and less than kind of cancel out?
It overlaps.
Yeah.
Yep. So in set theory, it goes like this. We have one set here, which is x is greater than or equal to k. We have another set here, which is x is less than or equal to k. When you have a conjunction, you're looking at the intersection of the two. And in this case, the only intersection here is going to be x equals k. And that's why that's the answer. All right, so I'll see you guys on Thursday and work on the nested statement homework assignment.
Can you look at this one? That's pretty sure it's right, but I'm not sure.
Okay, I can only look at the certain key points and make sure that that part is right.
Okay.
So the key point here is, well, we know this is going to be new, so on line 4 here is where we get here.
It's fun when you get it, but when you don't, it's
Yeah. False.
I'm glad there wasn't a quiz today. I figured that out.
All the way down to line 12. Yep. So that's
Yeah, I'm actually moving up to another class, 1:30.
the only other point is going to
Yeah, I went to the office hours and I asked if I could. Because had people drop in that class, so I didn't want to go early in the morning.
is false.
So now I'm going to go to that class.
And then
I went to the next if then after that
Yeah,
point.
maybe he has his photo, but you could.
Well,
you have to go to the else corresponding. If there is an else corresponding to that,
To each his own.
else corresponding to that.
well, so okay, so that's my question is.
I'm going to try to
So
get.
this is when I get to here, and this is why I put the question mark right at that spot.
So that
Yeah.
first.
X
See how that
is
goes.
greater than 2, which is false.
That's fine. I'm just going to close the
I want it.
recorder.
Recorder? Oh, okay.
Yep.